In this video, we'll try to understand what exactly is solid. Solid is nothing but it is 5 basic principles which helps us to create good software architecture. Solid is an acronym where S stands for SRP, that is single responsibility principle, O stands for OCP, which is open close principle, L stands for LISCO principle, I stands for interface segregation principle, and D stands for dependency inversion principle. So what we'll do in this video is, let's start understanding each one of these principles with simple C# examples. So the best way to understand solid is by understanding what problem it solves. When we talk about design patterns or any kind of architecture solutions, right, all of these solutions are created because there was some problem they were trying to solve, right? In the same way, solid principles also try to solve some problems. So let's try to understand those problems. So what I'll do is, in order to understand those problems, let me go and create a very simple customer class here. And let's say this customer class has a very simple method here called as add method. Okay. Now I will not go and create a lot of properties for this customer class like customer code, customer name, because here I want to create very simple C# examples and make you understand solid, right? So let me keep the class as small as possible. So here's a very simple customer class, with a add method, and this add method, what it does is it actually goes and adds the customer class to database. Okay, so it goes and adds the customer to database. Now it's very much possible, when you add this customer class to database, right, or customer object to database, you can have exceptions, right? So what I'm going to do is I'm going to go and wrap this code into a try and a catch block. Currently, I'm not writing the code of database, because our main concentration here is to make you understand solid. So, this comment here, you can think about this comment as a comment, as a code actually, which will go and add this customer to database. In case you want to learn how to go and add data to the database, you can see the videos on ADO.NET Entity Framework, which we have in Questpon VD section. Okay, so currently, here we are just saying that there will be a code here which will go and add the customer to the database, right? So while this customer is added to the database, it's very much possible that you can get exceptions. So I have wrapped this code into a try and a catch block. Now in case we have exceptions, what we'll do is we'll write those exceptions into a file. So you can see here I've written a very simple code here. Again, my purpose here is to not demonstrate how to insert into database, how to write to a file, but the purpose is solid. So what I've done is I've written a very simple code here, and this code, what it does is, if there is an exception here, it goes and writes the exception into a file called as error.txt. So for that, this customer class is using the system.io namespace, and it is using the file class. Now have a look at the customer class very closely. Do you find some problem here? Let me give you a hint. There is a problem in this catch block. Yes, you guessed it right. This customer class is doing work which he is not supposed to do. So putting in simple words, a customer class should do customer validations. It should validate customer code, validate customer name. It should call the data access layer. But if you see the catch block closely, it is also doing logging activity. There is a Spanish proverb, which says that it's the overload which kills and not the load, right? So tomorrow, if you add a new logger like event viewer, or let's say you add a new logger like XML viewer, I need to go and change the customer class. That's very odd, right? It is like saying that, if Hari has a problem, then I need to go and check Suresh, isn't it? So basically, the problem here is the customer class is not doing one responsibility, it is doing multiple responsibility. So SRP, or single responsibility principle, says that a class should have only one responsibility and not multiple. So if we apply SRP here, what we need to do is we need to take this logging activity into some separate class, right? So in other words, the code would change something like this. So the first thing is to go ahead and create a class here, a separate class which will do error handling. So let me go and create a very simple class here called as class error handler. and this class will take away all the responsibility of handling errors from the customer class. So I'm going to go and cut this code from here, and I will go and create here a method public void handle error. This will take up a error string, and I will copy this code here and ERR, right. So now, the customer class can delegate the responsibility of handling errors to the error handler. So what I can do here is I can go here and create an error handler class, and I will go and delegate the handling of error to the error handler class, rather than handling the errors in the customer class. So you can see now here how the customer class is using the error handler class, to delegate the responsibility of error handling, rather than he taking care of it. So SRP, or single responsibility principle, says that a class should only take care of one responsibility rather than multiple responsibilities, right? Now, before I move ahead, right, I would like to make a small comment here specifically for the seniors. I know that, some of the seniors, who are working with design pattern for a long time and working with architecture or creating architectures, right? They would say that, remove this try catch block also, right? Why? Because the try catch block is something related to exception handling, and why even this try catch block is a part of the add method or the part of the customer class. So I fully agree to it. You can always take this try catch block and move it to a global file like global.asx and do the error handling, right? But for now, my purpose here is to make you understand the basics. Okay, so I know that you can take the solution and make it better to whatever extent you want it, but for now I want to keep it simple. I want to make people understand what is SRP, and then let your thoughts fly. Architecture is all about creativity. You can take this solution and take it to whatever greater level you want. Okay, so I know that people who are seniors, they can start pointing out small things, saying that don't do this, don't do that. But for now, my thought here is to keep this video simple, right? So SRP is saying that basically do only one responsibility and not multiple ones. So what we did is, this customer class was doing exception handling. I created a new class here called as error handler. He said that yes, I will take up the responsibility, and the customer class delegated the responsibility happily to the error handler class, and the customer class can now concentrate on validations. He can now concentrate on the database code, etc. So this is termed as single responsibility principle. Now let us work on the second thing from Solid, that is open close principle, or OCP. Okay, so let's try to understand what exactly this OCP means. Now, in order to understand OCP, let's continue with the same customer class. Let's say we, in this customer class, I go ahead and I add a method called as calculate discount. So this method actually calculates discounts, right? Now this calculate discount method will use a customer type to do discount calculation. So in other words, we will have various kinds of customers or various types of customers, like gold customer, silver customer, bronze customer, and depending on the type of the customer, this calculate discount method will work. So what I'll do is, let me go ahead and create a simple property here, and this property I will name it as customer type, right? And depending on this customer type, the calculations will be done. So this calculate discount, will have logic something like this. So it will say if customer type, let's say 1 is for gold and 2 is for silver type of customer. So if he's a gold customer, in other words, he is buying a lot of things from us. So let's give him a discount of 10%, right? And if he is a silver customer, so other than 1, everything is a silver customer, we will return him a 5% discount. So you can see here now, depending on the type of the customer, right? Very quickly, let me just go and minimize this fonts here so that we can see the whole thing, right? There it is. So you can see now, depending on the type of the customer, the discount calculation is happening. Now think for a moment, watch this customer class closely, and you will see that there is a slight problem we have here, which is from the customer type perspective. Okay, and if you want a hint, you can see this if condition here. This if condition is a serious problem. In other words, tomorrow, let's say, if I want to go and add a new customer type, let's say a bronze customer, I need to again go and change this if condition. If let's say tomorrow I want to go and add, let's say, one more customer, which is a free customer type of customer, again I need to go and add some more conditions in this if condition, right? So in other words, every time I add a new customer type, I need to go and change the customer class. In other words, this modification also has a lot of repercussion, right? In other words, when we modify the customer code again and again, we also need to ensure that we test the functionalities again and again, so that the previous functionalities are working as they were working before, and the new functionalities also we have to test. Second, the connected clients who are consuming this customer class also needs to be tested. So we should ensure that there is no side effects of these changes, right? So we have to go through everything again, if we are modifying the customer class, right? So how about changing our thought process? How about rather than modifying the customer class, we go for extension? In other words, every time a new customer type needs to be added, we just go ahead and create a new class. So what will happen is, the current code will remain untouched. So that means, whoever are the existing clients who are consuming this customer class, they will work as they were working before, right? And we just need to go and test and check the new classes. Now, if you try to visualize this differently, right? What we are trying to say here is, close this customer class for modification. Do not allow any kind of modification on this customer class, but keep the customer class for extension. OCP, open close principle. Close the class for modification, but keep the class open for extension. Also, I would like to put some more clarity around this word modification, because people who are newcomers and freshers, this modification word, sometimes they take it in a very different way. Modification here does not mean fixing of bugs. For example, now let's say if there was a defect here, you shouldn't say, okay, now there is a defect, but I will not modify the code. No, you have to modify the code. That is not modification. Let's say you have some naming convention, and then later on you want to make it better. Yes, modify the code for it. That is fine. Okay, so modification does not mean basically fixing defects or modifying your code for betterment purpose, right? Modification here means adding of new functionalities. For example, when I'm going to go and add a new customer type called as bronze, new customer type called as silver, that is called as modification. Modification means adding of new functionalities. Okay, because a lot of time I see people who are freshers, they take things as it is, as a silver bullet, right? So I'd like to just clarify here, modification does not mean fixing of defects or basically changing your naming convention, but it means adding new functionalities. So now the next thing is, so how do we go and implement OCP over here? So the first foremost thing what we need to do here is we need to get rid of this customer type, because this customer type variable is the main reason of the if condition, right? So let me get rid of this first. So let me go and delete this. So now let's consider that this customer class is an ordinary customer class. Okay, in other words, it represents an ordinary customer where there are no discounts. So I'm going to go and say that, okay, this is an ordinary customer class. This class represents an ordinary customer, and the discount calculation for the ordinary customer is 0%. In other words, there are no discount for ordinary customer. Okay. Also, as we discussed previously, that rather than going for modification, we would like to go for extension. So we would like to go and provide some way by which we can go and extend this calculate discount method. In other words, we need to go and mark this calculate discount method as virtual. Why virtual? So that classes can further extend it and they can provide their own implementation. Until you don't provide a method virtual, you cannot actually go and override it, right? So you can now see this customer class represents an ordinary customer, right? A simple customer which has no discounts. Now in case I want to go and create a customer type of gold, I need to just go and extend this customer class. If I want to go and create a customer type of silver, I need to go and extend this customer class. So what has happened now is, we are now moving towards the methodology of extension rather than modification. So now let's say if you want to add a new customer type, what I'll do is I'll do a inheritance, or I'll do an extension. So I'll say here, okay, I want to add a new customer type called as gold here, and I'll say that, okay, now go ahead and inherit from the customer class, and now the gold customer, let's say it returns 10% discount. Okay, so for a gold customer we have kept 10% discount. So what I'll now do is I'll go and say, okay, override calculate discount and return whatever is the base discount plus 10. You can now see that how I am creating new classes rather than modifying the customer class. In other words, this customer class is now closed for modification, but it is open for extension or inheritance. This is termed as OCP, open close principle. So let's move ahead with the next solid principle, L. L for Liskov substitution principle. So what we'll do is let's continue with our same customer class ahead. So now let's say, we have a gold customer. In the same way, let's say we go ahead and we create a silver customer. Silver customer discount is, let's say, 5%. So I create a new silver customer. I follow the open close principle and I go and override the calculate discount, and I'll say return the base plus 5% more on it, right? Now let me go ahead and add one more customer here, and this customer I'll term it as inquiry customer. These inquiry customers are those kinds of customers, who actually come to your shop. They talk about the product, they ask about the product, they bargain, but they don't buy it. Okay, so basically, so you can see here I've created one more customer type here called as an inquiry customer, who actually does not buy any kind of product from the shop, but he does an inquiry in the shop. And because he's an inquiry customer, I just want to make sure that he actually goes and buys the product. So what I've done is, I have given him 2% discount. So just to woo him, I'm giving him 2% discount so I can convert this inquiry into a customer. Now, because this is an inquiry customer, he is not buying anything from me. He is not the real customer. I don't want to save this customer to the database. Okay, so what I'm going to do is I'm going to go and override the add method, and over here I'll say throw new not implemented exception, saying that for inquiry type of customer, not allowed. Okay, so if you visualize the current customer hierarchy or the current customer inheritance hierarchy, it looks something like this, as shown on the video. In other words, we have a customer class, and this customer parent class is inherited by the gold class, a silver class, and inquiry class, right? So as per polymorphism, in case you are not aware of polymorphism, please go and see the object-oriented programming questions and answers videos, where we have explained what is polymorphism. So as per polymorphism rule, my customer class object can point to any one of its child class objects like gold, silver, inquiry during runtime without any issues. Again, I repeat this sentence. So as per polymorphism rule, my parent customer class object can point to any one of its child class objects like gold, silver, or inquiry class during runtime without any issues. So let's go ahead and write a code and let's see if this works or not. So in order to see, if this polymorphism concept works or not, what I'm going to do is I'm going to go and create a list of customer. Okay, into this list of customer, I'll go and add different types of customer types like, let me go and add a gold customer, right? Because it is polymorphism, he will just allow me to go and add any kind of types which are of customer, right, into this list. Let me also go and add silver customer, right? Let me also go and add our inquiry customer. So you can see now, because it is polymorphism, right, I can go and add to this customer list any kind of customer which are of type gold, which are of type silver, which are of type inquiry. Also, because we are talking about polymorphism here, I can always go and loop through this collection in a very generic polymorphized way, I'll say. I don't know if that's the right English or not, but I can always go and do something like this. I can say, okay, go and browse, through this collection by using the customer class. Now, because the customer class is the parent class, this typecasting will happen by itself, right? So I can go and say, okay, go and browse through this obj collection of customers, and I can also go and invoke the add method in a very generic way, right? So you can see, polymorphism is working perfectly nice here. At least the compilation is happening. There are no errors over here. So I'm able to go and create a list of customer, add gold, silver, inquiry customer to it. And also I can go and browse through this collection and call the add method. Okay. Now let us go ahead and run this code. So from the compile time perspective, it is working very nice, right? Now let us go and run this code and let's see what happens. So I'm going to go and click on start here and let's see what happens. So there the program is running. So you can see now I'm creating a list of the parent object, that is customer. Now because it is a parent object collection, I can go and add gold customer, I can add silver customer, I can add inquiry customer. Because of the polymorphism behavior, I can go ahead and I can add any of the child objects to the parent object collection. And also I can go and browse through the collection. So I can take each one of those objects. So for example, you can see I'm taking up the gold customer from here. I'm invoking the add method. It works perfectly well. Then I take up the silver customer. I invoke the add method. That also works perfectly well. Then I take up the inquiry customer and I call the add method, and I get an exception here. If you remember right, I said that basically the inquiry customer, we don't want the inquiry customer to be added to the database, right? So in the add method, I had thrown up a not implemented exception, saying that this addition of the customer class to the database is not allowed, specifically the inquiry customer. So that's why this error is thrown here. Now let me try to summarize this problem. What has happened actually. The problem is this inquiry customer looks like a customer. In other words, it can calculate discounts, it has all the properties of the customer, but it is not a customer. So what's happening is the parent object cannot replace the child object seamlessly or easily. In other words, customer is not the actual parent of the inquiry class, because inquiry class is a different entity altogether. If you visualize the inquiry customer, again I'm repeating this sentence, inquiry customer looks like a customer class. It behaves like a customer class, but it is not of the type customer. It is, the people who do inquiries, they don't actually make a sale from us. So there is a very slight difference over here, right? So in other words, inquiry customer should be treated differently. It should not inherit from the customer class. This is termed as Liskov substitution principle. Liskov substitution principle says that your parent objects should be able to replace the child objects easily with polymorphism. But you can see over here where my customer object pointed toward the gold customer, no problem. Pointed to the silver customer, no problem. But the time it pointed to the inquiry customer had a different behavior. So in other words, this inquiry customer is a different thing altogether, right? So this is termed as Liskov substitution principle. The name substitution says that the child objects, the parent object should be able to substitute the child objects easily, which is not happening in this case. So if you visualize the business working right, there are two kinds of people who come to the shop. The first kind of people who come to your shop is who just do inquiries. Okay. And the second kind of people who come to your shop is who actually do the sales. So those are customers. So in other words, we have to create two categories of people. One person who just does inquiry and the other kind of people who actually do the sales. So in other words, what I'll do is let me go and create two interfaces here so that I can have the classification very easy. So I'll say, okay, I have two kinds of people who come to the shop. One who just does inquiry, okay, and the other one who does sales. So I'll call him as I customer. So what I've done here is I have just made the vocabulary in a proper way, saying that inquiry customers or inquiry people who come to my shop are not actually customers, and the customers are actually the people who actually will buy my product. Okay, so the inquiry people who come to my shop, they are interested in just knowing what kind of discounts I have, right? So normally people who inquire, right, they inquire more about the discount. So I'll say, okay, the people who come to do inquiries, mostly they come to know what kind of discounts I have. So you can see I've created here an interface called as I inquiry. Okay, so I put these guys into a separate bucket altogether, saying that these guys are only interested to know what kind of discounts they have, and if they like it, they will become a customer. This is inquiry N, right? Just some small mistakes there, right? Now the next kind of people are customers. So these the people who are customers, definitely, they first do an inquiry. So basically they would like to know, what kind of discounts you have. But, once, they do the inquiry, they would like to basically buy. So what I'm going to do is I'm going to go and have an add method here. So in other words, if a customer comes in, he does an inquiry, and if he likes it, you would like to go and save that customer into the database. So you can see here now, that Lisco problem I'm solving, by segregating, both of these guys into separate interfaces. So I say that, okay, I have two types of people who come to my shop, one who only does inquiry and the other one who does inquiry as well as he buys my product. So now, depending on what kind of class we are creating, we will implement either the iCustomer interface or we will implement the iInquiry interface. So for example, here for the customer class, I'll go ahead and I will implement iCustomer. And because this is the iInquiry class, which is not exactly a customer, so here I will implement iInquiry. Right. And for inquiry kind of customers, you don't need to have the add method, so we don't need this anymore here. And here I will say just return 2, right? 2% of discount. Let me go and just build this. So I'm going to go and build this whole thing. Right now you can see the build is done. Actually, it's giving some error here. No suitable method found for overriding. Let me just go and correct this. So let me go and re-implement the method. I'm going to go and say implement this interface here. But there it is. Yeah. Right. So let me go and build this. Right. And now you can see here, it's clearly showing me an error saying that this is a list of customer and you cannot add an inquiry here. Right. So in other words, now you can see that, there is no confusion between a customer and an inquiry. Okay. So I'm going to go and comment this. So I'll go and build this. Right. So now you can see, when I've created a list of customer, I can only add customer to this. I cannot add something which is not a customer like an inquiry. Okay. So that gives me a, error alert, while in the compiling time itself. So now I can happily go and, add the gold customer and silver customer, and I can happily go and, call the add method, and I will have no problems. My parent object is now pointing to the child object very seamlessly. Why? Because we have done the segregation properly, right? So Lisco principle says that your parent object should be able to point towards its child object easily. There shouldn't be any kind of errors or there shouldn't be any kind of problems. Okay, in case there is a problem, that means you need to go and segregate those classes differently. Okay, so this is termed as Lisco segregation principle. So we did single responsibility principle, we did open close principle, we did Lisco segregation principle. Now the next thing is I. So the Lisco principle says that the parent class should be able to replace the child class objects easily. There shouldn't be any confusion. In case if the child class objects are not replaced easily, that means those child class objects don't belong to that inheritance hierarchy, and probably you need to create a new entity like what we did, creating an inquiry object altogether, right? The next principle in Solid is I. I stands for interface segregation principle. Let me explain you what exactly is the problem which interface segregation principle solves. So you can see here, for example, now let's say, your customer classes, that is customer, gold customer and silver customer, they are consumed, by, let's say, thousands of clients. Let's say your customer class has become super hit and, it is used by thousands of clients. They are creating the customer objects, they're invoking the add method, they are calling the calculate discount, etc. And all of these clients are using the iCustomer to reference your customer classes. So at the back end, yes, you can have customer, gold customer and silver customer, but your clients are using iCustomer so that there is decoupling. So tomorrow if you add a new customer class here, the clients don't have to update. Okay, so a lot of customers are using iCustomer, they are happy with it, they are happy with the add method, they are invoking it, they are adding it, they are calculating discounts. Now let's say you get some new clients who say that they also want the read method. So they want calculate discount, they want the add method, Also, they want to read the customer data. So one of the but obvious thing, what a developer does is, or I'll say enthusiastic developer, or I'll say over enthusiastic developer does is, he actually goes and just adds a new read method to the iCustomer interface and then starts implementing in the below concrete classes, that is your customer class and gold customer class. You will start writing the read logic, for this iCustomer. But hang on, if you do this way, you are ending up into a serious problem. The problem is, as I have said previously, this iCustomer is now used by thousands of clients who are satisfied, who are working very nicely, they have no issues, and they do not want the read method. They are happy with the add method, they are happy with the calculate discount. Now, if you are going to go and update this interface here, that means you need to also go and update all your clients, right? And updating thousands of clients is a big job altogether, right? So how do we solve this problem? So the way to move ahead from here is, rather than going and updating the current iCustomer interface, what we can do is we can create a new interface called as iRead, and this iRead interface implements the iCustomer. Okay, so what will happen now? This iRead interface has the read method, the iCustomer interface has the add method. So whoever are your old customers, they will only get the add method, nothing changes for them. But whoever are the new customers, they will get the add method as well as they will get the read method. Okay, so this is termed as interface segregation principle. In other words, we have segregated the interface. We have said we are not going to go and update the old interfaces. So the old clients work as they were working previously, and the new clients, get those extra functionalities which they need, as well as they get the old functionalities. So now the old 1000 clients, your 1000 happy clients, will be using still the iCustomer, right? So if you see here, this I old, right, is calling the add method, and you can see he has no reference of the read method. Why? Because he is not interested, right? And the new clients, right, they will be using the iRead method, right? These are the new clients, and the new clients will get both the facility. That means they can definitely use the add method, as well as as per their new requirement, they can also go and invoke the read method. So you can see now the old clients are not disturbed at all. They are as they are behaving, and the new clients are getting the new functionality. This is termed as interface segregation principle. In other words, show only those methods or show only those functionalities to a client which they want, rather than showing them everything. So now we are on the final principle of Solid, that is D, dependency inversion principle. So let's again continue with the same customer class, so that we have only one example, and in that one example we'll try to cover everything. Now if you remember, when we started with SRB, we talked about this error handler class, right? So if you remember, we said that customer class was doing too much work, so we created this error handler class here, and this error handler class will be used to do error handling rather than the customer class doing it. Now let us say we have different types of error handlers. Okay, so for example, you can see currently the error handler which we have is a file error handler. In other words, if any error comes in, it will actually be written to a file. But now let's assume that we want to create different kinds of error handlers, like event viewer error handler, we want to create a XML error handler, we want to create a file error handler. So what we'll do is so because we're going to have so many different kinds of error handlers, and it's also possible that tomorrow we're going to add new error handlers, so we'll first go ahead and create a very simple interface here. So let's go ahead and create an interface here, and let's name this interface as I error handler, right? Okay, and this interface will have a method here called as handle error, right? So all of the error handlers will implement this I error handler interface, right? So for example, let's say now this is a file error handler, so he will actually implement I error handler. In the same way, let's say you are creating let's say a event viewer error handler, right? Event viewer error handler, so this will again implement I error handler, right? So here I will have the logic of, here I will write a logic, which will handle errors in event viewer. Okay. So in this way, now I can go ahead and create different kinds of error handlers, using this I error handler. And what I'll do is, in my customer class, rather than referencing what you call this error handler class, strongly type error handler class, or I'll say concrete error handler class, what I'll do is I'll reference in this customer class just the I error handler interface. Okay. And this I error handler interface, then I will go and say, okay, to this I error handler interface, do I want to create a file error handler, or do I want to create a event viewer error handler? That's all up to me. Okay. So let's say for now, I'll just say that, okay, I want to create an event viewer error handler. And over here, I'll say I error handler dot handle error ex.toString. Okay, great. So now what I've done is, I have created a very generic interface called as the I error handler, and this I error handler can point towards event viewer error handler. It can point towards file error handler. So in this way, I have controlled the decoupling between the customer and the error handler class to a certain extent, right? But now let's say we want that depending on certain parameters or certain configuration, we would like to either create an event viewer error handler, or we would like to create a file error handler. Okay. So rather than hard coding like this, let's say you have some value in your app config file, and after reading that value, while the customer object gets created, or in the constructor of the customer object, here you will write some if condition saying that, okay, if the value is 1, then create what you call a file error handler, right? Or else, if the value is something else, right, then you create something else. So you'll say, okay, this is IERR is equal to new event viewer error handler, right? So depending on conditions, right? Now this condition over here, I'm not going to write a code here, but let's say this if condition is probably reading values from an app config file, or it's reading a value from a parameter table. I don't know from where this value is coming. But depending on this value, the customer class then decides, okay, I'm going to use a file error handler, or I'm going to use a event viewer error handler. Now this code is problematic, right? Why? Why is the customer class taking the decision, or why is he taking that extra load? Again, going back to SRP, single responsibility principle. Why is he taking the load of deciding which error handler class to be created? Why can't this decision making of creating this error handler class object should be given to some other guy? Because what is the work of customer class? The work of customer class is to check customer code, to calculate discount, to call the add method, to call the update method, whatever it is, right? But if you see now, again, we are violating single responsibility principle here, saying that this decision making is currently controlled, or it's done by the customer class, which is again bad, right? So how do we go and remove this decision making from here? And if you watch very closely, the problem is this new keyword. This customer class has taken the responsibility of creating objects. So how about, if the customer class says, okay, I will not take this responsibility of creating new objects, and this responsibility I would like to invert to someone else. So how about he's saying that, okay, I'm not really worried what comes to me. So in other words, he says that the client who is creating my object, right, or the client who's going to consume me, if he can pass me what kind of error handler has to be used, then that would be great. So in other words, you can see here what I've done is in the customer class constructor, I'm saying to the client, please pass me the type of error handler you want me to use. Okay, and here I'll just go and set this value. So you can see now here the customer class is only referencing to this interface, I error handler. He is now not concerned that basically he's going to get in a file error handler, he's going to get an event viewer error handler, or a mail error handler. He just says, I am referencing to the generic interface. Now what comes to me is all up to the client, who's going to consume me. So now it's the client's responsibility. For example, here if you see, this customer class is consumed in this static void main, right? So now he decides, he says that, okay, I want to use the file error handler, right? Or here he says, okay, I want to use the event viewer error handler. So if you see here, what has happened is I have inverted, or I'll say the customer class has inverted, the customer class has delegated the responsibility to the external party who will create the object. This is termed as dependency inversion principle. That's the last part of solid D. Dependency inversion principle says that, we will only refer to abstraction and not to the concrete classes. So here, if you see, the customer class currently is only referring to this abstract or the generic interface, that is IError handler. He is now not concerned, will he get a file error handler or will he get an event viewer error handler. Now this dependency inversion principle also has a lot of other forms like inversion of control and dependency injection. So what my suggestion is, please go to the design pattern section and watch the videos on dependency injection and inversion of control. Okay, so because this dependency inversion principles, you can implement in multiple ways. For example, currently I implemented it via using the constructor here, but a lot of people can use dependency injection, or they can use some other ways of doing things. Okay, so please do go and see the video of inversion of control and dependency injection to understand how this dependency inversion principle is available in different other flavors. So let's quickly go and revise what we have learned about solid. So solid principles are nothing but those are principles, if you follow, it will make your architecture better. So solid is an acronym where S stands for SRP, that is single responsibility principle. In single responsibility principle, the class should only take care of his work rather than taking responsibility of other classes. Okay, the second one is OCP, open close principle, where rather than modification, we prefer extension or inheritance. The third L stands for LSP, Liskov substitution principle. A parent object, while doing polymorphism, should be able to replace its child object seamlessly, right? The fourth one is ISP, that is interface segregation principle, where the client should not be forced to use methods which he does not want to use. Okay, so if you remember, in the code, we had created two different interfaces, and depending on the old client and the new client, those interfaces were used. And the last principle which we just covered is the D, that is dependency inversion principle, where the class will actually point towards the abstract layer, and the creation of the concrete objects will be given out to someone else. It will be inverted out or delegated out to someone else. So if you remember, in our customer class, we just refer to the IError handler. Now, to that IError handler, if somebody is passing a file error handler or they are passing an event viewer error handler, the customer class is not worried about, right? So solid stands for SRP, OCP, LSP, ISP and DIP. So I hope that you enjoyed this video. In this video, we were trying to understand what exactly is solid, and we also saw a simple example of a customer class, and we went through a complete demo of understanding these principles one by one. Thank you so much.